So we want to be able to figure out the slope using that formula that we just talked about a minute ago, y2 minus y1 over x2 minus x1. Let's do that. So these are the 2 points that I have here that we're working with. So what I'm going to do is I'm going to label this one x1, y1, and I'm going to label this one x2, y2. So it's going to be very consistent with the picture that I made here. So you have 2 points, basically. So from that, we can use our slope formula to get the slope. y2 minus y1 over x2 minus x1 is the formula we need. So y2, you can see it's 9, right? y1 is 3. So that would be y2 minus y1 is 9 minus 3 divided by x2 minus x1. So that's negative 1 minus 2. So 9 minus 3 is going to give me positive 6. Negative 1 minus 2 gives me negative 3. So I get 6 over negative 3 is negative 2. So thus, slope is m is equal to negative 2. Any questions? Okay, so now we have the slope. So let's say they want you to write the equation of the line in slope-intercept form. So you know that's y equals mx plus b. That's the slope-intercept form. So there's going to be some algebra that has to be performed to be able to do this. So what do I know? I know my slope already. We found that from part A is negative 2. Now, we have 2 points that lie on the same line. So I can choose either point, right? I can choose either point. The first point, 2, 3. Or I could choose negative 1 comma 9. It doesn't matter. I'm still going to get the same answer either way. So we need the slope. We have the slope. We need to figure out the y-intercept. We don't know what that is. So I'm going to choose this point over here. Okay, I could choose this one too if I wanted, but I'm going to choose this one, 2, 3. So I know m is negative 2. 2 is an x-coordinate, which is my x, and 3 is the y value, which is the variable for y. So what I have is I have m, x, and y, but I don't have b. That's what I need. I have to figure out the y-intercept. So we have basically 3 out of 4 variables here. Okay, so we have an equation, right? We have y equals mx plus b is the form of the equation. So y equals mx plus b. So I already know y is going to be 3, right? So I'm going to put in 3 for that. I'm going to put in negative 2 for m because we got that from part A. I'm going to put in x is 2. So I'm going to put that in for that. And I don't know what B is. That's what we're trying to find. So just have to solve this. So this is going to be -2 times 2 is -4 plus B. So B plus -4 equals 3. So all I have to do is add 4 to both sides here. So I can get this B by itself. So what am I going to get? So 3 plus 4 is 7. That cancels out. So I just get 7 is equal to B. So what do we know? So we know that M is -2 from part A. We know the y-intercept B is 7. So y equals mx plus b. So I'm just going to say that y is equal to -2x. You have to replace. Let me actually write it down here instead. Let's do it over here. So -2x plus 7. That's it. Very simple. Replace your m and your b value in the form, and that's basically what they want for part B. Now I could have also used this point over here. If I had used -1,9, I still would have gotten the same value. I still would have gotten 7 for the y-intercept. But I chose to use this point. So either point is going to work. That's the key, either point.
So in the final form for the slope form equation, you're just plugging in M and you're just plugging in B. You don't plug in X, you don't plug in Y, even if you have it.
So what will happen is if I plug in my X values, it's going to match. So if I put in 2, I'm going to get 3, right?
Uh-huh.
Into this. If I put in -1 for X, I'm going to get 9 into this equation.
Uh-huh.
That's what it means. That's what I meant when they lie on the same line, right? If I plug in the X values, I'm going to get the Y value because the Y values depend on the X values.
Mm-hmm.
That's what that means.
Okay.
So again, I can graph this, right, to see, we could find the X and the Y intercepts again. Let's find the X and Y intercepts. X and Y intercepts. So we have an equation now, right, that we can work with that we just found in part B. So the process is still the same. If I want to find the x-intercept, that's the point at which the line crosses the x-axis. So again, when something's on the x-axis, the value of y has to be 0. So this is no different. So I'm going to let y be 0 and solve for x. Let y be 0, and then we solve for x, right? So I'm going to put in 0 for y and let everything else stay the same. So if I minus 7 on both sides, I'm going to get 0 minus 7 is -7. That cancels out, so that's -2x. So if I divide by -2, I get 3.5. So a negative over a negative is positive. 7 over 2 is 3.5. So x is 3.5. So therefore, when x is 3.5, y is 0. That's the x-intercept. This would be your result.
For problems like this, but you want us to convert it into decimal point form instead of leaving it as a fraction?
Doesn't matter. I'm going to know what it is. I know what a fraction is. Yeah, it doesn't really matter too much. I think it's better to keep it as a decimal because, well, you could also keep it like this. You could also say 3.5, 0. It's still the same thing. So when you graph it on the plane, it's easier to see it. If I leave it as 7 over 2, you might not know that's 3 point something. But here I can tell that it's between 3 and 4. So it's easier to place it on the graph, I think. Either one of these. Okay, that's the x-intercept. So what about the y-intercept? So this is a point at which it crosses the x-axis. This is a point at which it crosses the y-axis. So we actually already know what it is. We know it's going to be 7. Let's prove it. So I'm going to let x be 0 and then solve for y. So we have our equation, negative 2x plus 7. So I'm going to say y is equal to negative 2x. That's going to be 0 though, right? Plus 7. So negative 2 times 0 is just going to be 0 plus 7. So we get y is equal to 7. So therefore, when x is equal to 0, y is equal to 7. This would be your y-intercept. Okay, so we can graph this to see what it will look like. So it's easy to graph it just by putting it on a Cartesian plane like this. So I'm trying to graph it as accurate as I can, but let's see what it'll look like. All right, so let's graph the points. So the points that we were given were the first 2 points, 2, 3 and negative 1, 9. So I should have actually gone higher. Why did I go lower for? Let me go a little bit higher up on this. A little higher. All right, so 2, 3 is the first point. And negative 1, 9 is the second point. You write it on this side. So negative 1, 9 is like here. And we found the intercepts already. So we found that the intercepts were 0, 7. So here's 9, 8, 7. And 3.5, 0 is the x-intercept. So 1, 2, 3, 3.5, 0. So you see how they all lie on the same line, basically, if I connect the dots. Here's the y-intercept, 0, 7. And this is the point 2, 3 that was given to us in the problem. And this is the point negative 1, 9, which was given to us. So here are all 4 points. As you can see, you have the idea of what this looks like. They all lie on the same line. Okay, so 0, 7, 3.5, 0. I labeled them. Any questions? Okay, so let's look at an application problem involving lines.